Hello all, my name is Deep Ranjan. A very good morning to all of you. So this is the continuation of the previous video as we are doing American Sign Language project. So in the first video we have seen the problem statement of that particular project, and the second video we have seen how to do a model training, custom model training using YOLO V4 Tiny. So after did the training, okay, what we have to do, we have to do a prediction. So in this video we are going to do a check prediction, like we are going to check how our model is performing. Okay, so as I told you, like I have trained my model of around 17k, okay, around 17k steps I have trained my model. Okay, and from that I got the accuracy of almost 93.25 or something around that. I got the accuracy. Okay, fine. So what I did here, after done the training, I have saved that model. Okay, so our model will be saved inside the backup folder. Okay, inside darknet there will be a folder called backup. Okay, and inside that model will be saved there. So you just need to download those weights. Okay, so that model will be in the form of weights. So that's why so I have downloaded that weights and I have given the name ASL best weight. Okay, American Sign Language best weight. And one more thing we have to download from that particular darknet folder. There is a CFG folder inside that, and that will be with the name of custom YOLO v4 detector.csv file. So we have to download that particular file as well and keep it inside this directory. Okay, this is the CFG file. Okay, asl.cfg file is there, and everything is mentioned there, like model training, like we have taken the batch size, width of image, channel, this kind of things are mentioned there, nothing else. Okay, so coming to the prediction part, so I have written a script for that. So we are going to check the prediction with the help of OpenCV. Okay, so what we are doing here, we are just simply importing CV2 OpenCV library and the time. Okay, and this is for the time, just for checking the time and all that, we are importing this time library. I have taken a confidence threshold of 0.5. You can increase that as well. Okay, no issue with that. And NMS threshold, non-maximum separation, this is a given 0.4. You can increase that as well depending on your requirement. No issue with that. And color, I have taken this is a green color in the RGB format. I have taken that, like whatever bounding box it will create, that will be of a green color. So in this current project we have the classes name, that is ABCDEFGH from to Z. Okay, we have 26 classes, so I have given that classes name are there. So now what we are going to start, we are just using the OpenCV. There is a method inside OpenCV CV2 video capture. Okay, so what I am doing here, I am just doing this prediction with the help of a particular video. Okay, if you want to do it from your webcam, you just need to like delete this thing and sorry, let me do a control Z. Yeah, what you have to do, you have to just delete this thing and you have to put a 0 there, so it will take your current ISO webcam port number, webcam port. Okay, nothing else here. So actually in my system webcam is not available, so that's why I'm doing with the video. Okay, and after that what we are going to read here, we are going to read here the weight and the CFG file with the help of DNN and readnet. That is because it's a darknet model, right? So that's why we are needing this particular library to read that particular weights. Okay, and after that we are saving these weights inside this model. Okay, and also we are setting up input parameter because we have already trained our model on with the size of 416 cross 416. Okay, so we have passed the input size of 416. Okay, and also we are doing here the scaling. For scaling, what we are doing, we are just dividing it by 255. Okay, and swap RB is equal to 2. So this is just a parameter kind of a thing. You can change this thing. You can even skip that path as well. Okay, it's not a mandatory thing, but you can keep it. I have kept it. Okay, and these two lines are just for the video recording. Like we are getting whatever prediction we will get. Okay, so it will record that particular prediction, and so that we can use it for the future purpose. Okay, as I already recorded that video as well. So then after that what it is doing, we are just running that video. So whatever output that it will taken. Okay, so this video will start capturing. Okay, and it will start. Okay, so uh, when your video will start, it will take give us two values. Okay, one is frame and one is grab. So grab is something called as a return as well. Okay, you can say that return. So if it is not returning anything, so it will just exit. Otherwise, if it is returning a frame, okay, if it is reading a video, if your video is correctly fine, okay, is available, so definitely it will read that image and all the fine will be there. Okay, and what next it is doing. Okay, so we are just doing the model dot detects on that particular frame with that confidence threshold that we have already defined here, 0.5, and the non-max separation of 0.4. we have mentioned in time is equal to time. This is just for time, like starting time and ending time. We are just taking like how much time our model is taking to predict something on a particular frame. That's why. And also I'm just taking another time start drawing. So this one why I'm taking. So when I'll do the prediction now, so it will just in that particular frame it will show the how many fps and how much time it is taking to predict that particular bounding box. It will say that, nothing else it is going to say. And after that, when we got this values class id, scores and boxes, then what we will do, we'll just do a for loop there, and we are printing that with class id and color is just for the creating the bounding boxes. So it will just create the bounding boxes of that particular color that we have selected. So we have selected this only single color, that is of green, so it will take that particular color. And after that, what will we do, so it will label it like a class name. So there will be a name, and with their values it will count that particular values as well, and it will return on that particular frame. Okay, and there will be a bounding box cvt.rectangle. So inside that rectangular box there will be a frame, image will be appear, and the boxes will be appear with the color of green, and 2 is for with is just for thickness. Okay, something like that. Okay. And also we are putting that fps values on the frame. So cv2.putText method is there, so it's on which what we are doing, we are just putting that frame fps values and all that. So that is fine. And after that, what we are doing here, out.write. so out is for the video capturing. Okay, so it is recording that videos, and after that, once the everything will be done, so that particular frame will be saved inside that. It will write particular frame. Okay, and also it will and after that there is a cv2.IamShow method is there. So on IamShow method, what it will do, it will just show us like what kind of a prediction it is showing. So let me run that project as well. So let's see what kind of output we are getting. Okay, so this is the particular video that it is playing. Okay, just wait for a couple of seconds. You can see that fps it is showing, even that line. Okay, drawing time of a line 0.1 ms second it is showing. Okay, so still it is not started. Okay, because the fps is low. Even the 30 fps will be the real time, but it is saving the fps of 3. Just wait for a couple of seconds. Okay, it will show definitely some kind of a prediction. Okay, so actually I have recorded this video earlier because I was getting a fps of very low, so it will take a very lots of time for the prediction. So you can see that now it is started predicting. So you will see sometimes it will detect as a bounding because the fps is low. So it is not you can't say that it is a real time, but it's a YOLO v4 model is there, so it's a real time. If you use a gpu, even in my system there is no gpu, so that's why I'm getting a very low fps. Otherwise, if you have a gpu in your system, you will get a better fps, like almost 12 13 or more than that as well. Okay, so in that fps I don't think so we will get a particular value. So you can see that there is a c, and it is also predicting c. Okay, fine. So I have already recorded that particular video for that, so I'm just closing that. Okay, so this is our prediction part. Even we can do this prediction with the help with images as well. We have to just pass the images path here, and same thing, just you have to run that, and it will provide the prediction on that particular image as well. Okay, so that is for the prediction. In the next video we'll try to do like a fast Flask integration with this model. Okay, and even we will try to do some kind of a deployment as well. Thank you guys, bye bye.